Okay, all of you, good afternoon. Good afternoon, all of you, online and offline. Arya, Subhash, Manas, Jaivir. Yeah, good afternoon. Yes, we'll do that. Don't worry. In fact, I try to spend the first 15-20 minutes revising what we have done. And I have not yet gone after all of you, the new ones, for synopsis writing. But eventually that's part of your deliverables. Okay? So we'll do that. And when I'm revising, it's a nice habit if you can also keep writing as I speak, or at least check your synopsis while I'm teaching. Keep the synopsis agar hai aapke paas, rakho on the table and keep checking whatever we are revising. Hi Tushar, Akshay, good afternoon. Hi Arun. Okay. We'll start off now. So, interiors of Earth. We're discussing the layerings. We have the chemical differentiation, and we have the mechanical differentiation. The chemical differentiation is based on the composition and the associated properties, and this is based on rigidity. So one of you asked me, how is rigidity different from density? Okay, at a very crude level, when I say rigid, it's basically about whether a body is capable of resisting deformation or not. Can you deform something? Yeah, it toot jayega. Think of an iron slab. Okay, I can deform it or not. Or think of a glass slab, shishe ka slab. I can deform or not. What I can't deform is more rigid. What I can deform is less rigid. Okay. And density is the amount of matter inside that. It's mass per volume. कि आप एक volume उठाते हैं, उसके अंदर में कितना material है. That's density. So something which is heavy is not same as something which is hard. Say quartz. Quartz is a crystal. Quartz is light. But quartz बहुत hard है. There's something called as Mohs scale in study of crystals. Okay, diamond is the hardest. The second hard will be quartz. Quartz is used as cutting also, cutting tools में. So grinding करते हैं. They use sand. You know sandpaper जानते हैं, right? Sandpaper. Why can't sandpaper grind? Because sandpaper has quartz crystals. So what is hard is not same as what is dense or what is heavy. Okay, so यही example है glass sheet. Glass is light, हल्का है, but it will not deform, वो टूट जाएगा. Think of mercury. Mercury is dense, भारी है, but it is a liquid, it will flow. So you take a mercury, the glass will float on it. Okay, so glass is lighter, but it is rigid, वो टूट जाएगा, it is brittle. Whereas mercury is heavy, but soft. So hardness and rigidity are not the same things. Okay? So one of you asked this question to me. So when I say rigidity, I mean very crudely put, this is something like hardness. And anything which is very hard, it'll break. Like it'll become this, breaking is called as brittleness. Brittle. B-R-I-T-T-L-E. Okay, so lithosphere, halka hai, lighter hai. It's floating. And lithosphere is also, okay, brittle, toot jata hai. That's how we have the plates of lithosphere. Astronosphere is heavier, denser, but astronosphere is softer. You apply pressure on it, it'll deform. So the crust, oceans and continents, along with the part of upper mantle, okay, they are lighter, but they are cold, they are brittle, they are broken into plates. Astronosphere, the lower part of upper mantle, it is softer, but it is dense. Density is approximately 4-5 tak jayega density of the astronosphere. ठीक है? Yeah, hi Akshay, good afternoon. Tushar, good afternoon. Okay, so they're explaining some terms we use here. And in the chemical differentiation, we talked about the crust, we talked about the mantle, we talked about the core. Crust के 2 part हैं, mantle के 3 part हैं, and core के 2 part हैं. I can have continents, we can have oceans, upper mantle, middle mantle, inner mantle, outer core and inner core. And I believe you know the values, क्या depth में है, what are the minerals, what type of rocks, liquid है या solid है, okay, whatever, okay, you know the properties here. And in this we also discussed the discontinuities. These are those separation layers where one layer ends, another layer starts. In many cases, the transition is very smooth. Okay, you'll not know where one ends and where another starts. But in some cases, the transitions are relatively more abrupt. The abrupt hoga, I can definitely have a kind of a boundary. So not all layers will have a differentiating boundary. जैसे कि the upper mantle and middle mantle में the difference is very gradual. You'll not know where upper mantle ends and where the middle mantle starts. It's a zone. So we don't talk about discontinuity there. But in case of crust, I exactly know where continent ends and where the upper mantle starts. Okay, so there are 15 discontinuities, but हमारे लिए ये 5 is okay. Let's remember these. एक है Conrad बताया था मैंने आपको. One is Moho, one is Birch or Repiti, the Cuttenberg and the Lehman. Okay, the Birch, the Conrad one is inside the continents. Conrad is not in the oceans. Continents are thicker. Continents will have more variations in the depths. The upper layers are far more lighter, far more less dense. The far more felsic layers, you go down, they become a bit more denser. Okay, so Conrad hai. Then we talked about Moho. We talked about Repiti or Birch. We talked about Guttenberg and Lehman. Lehman's discontinuity is between the outer core and the inner core. So आपको याद रखना होगा. One of you asked me a question, sir. Does the lower part of the continents does it become similar with the oceans or not? अगर ये continent है and this is the ocean like this. Okay, this is the Conrad's layer at around 15 or 20 or 30 whatever kilometers. This is the upper felsic layers, and these are the lower mafic, relatively mafic layers. Then is this layer almost same as this layer or not? Answer is no. काफी similarity होगा. Okay, otherwise अगर same होता so then I would have drawn the diagram like this, no? I would have drawn this as a diagram कि यही ocean जो है, okay, ये यही यहाँ पर आ गया और क्या? Then the idea the continent is over ocean is right. Okay, but this is not how it is. Okay, so this layer is not same as this layer. ये layer बहुत अलग है. This is the ocean basalt. This is the ocean mafic. This is like mafic, but not as this one. अगर तो same होगा, then I can't differentiate. The whole thing is one layer. It's like, you know, in many ways, okay, man and primates, apes are very similar. Okay, but does not mean they are the same things. Of course, we have an exception. Parliament में अलग होता है. Okay, otherwise most of us are different. Okay, Parliament में तो वो carnivores भी हैं वहाँ पर. Okay, हम इंडिया की बात ही नहीं कर रहे. Okay. हम तो बेटा कभी इंडिया की बात ही नहीं करते. इंडिया तो is God's gift. It's heaven. Okay, it's fortunate to be here. Pakistan. Okay. That is, yeah. So they are not exactly the same things. ये अलग layer है और ये अलग layer. They are more towards mafic. They are more towards mafic, whereas this is actually mafic. इसको हम basalt नहीं बोलेंगे, but this is definitely the basalt layer. ठीक है. Lower layers are felsic. मत बोलो ना प्रिंट हम बता रहे हैं कि ऊपर को बोलो felsic and call this as relatively mafic. Okay, ताकि आप differentiate कर पाएं. Ultimately, continents are different from the oceans. That's the language used, and that's good enough. Basalt, then, if it's not basalt, then what is composed of? कुछ अलग rock है. It is some other rock which is like basalt but not basalt. आपको तो मैंने 2-3 नाम बताया है. There's a whole range of couple of hundreds and hundreds of rocks. We don't need all the names. Even I will not know all the names, so ignore it. Let's move on from there. ठीक है? Okay, that's one discussion point. Then we moved on towards discussing the mechanical division on rigidity. ये एक problem है कि people ask me, sir, tell me astronosphere कितना नीचे है crust के? So we don't talk like that. ये अलग scheme है. Okay, and the astronosphere वाला अलग scheme है. In the astronosphere, you talk about lithosphere, astronosphere, mesosphere. I don't use the word crust here. Actually, crust is part of this itself. This is the crust plus the upper part of the upper mantle. और ये दोनों मिलाकर, this is about 100 kilometers का thickness. So ये दो अलग schemes हैं. And this is that semi-molten one, which can get deformed. It allows for the above layers to float in it. And I had a brief conversation how the old model said the continents float over the oceans. Now we say no. It is continents and the oceans together, side by side, as a part of lithospheric plate. They together float on the astronosphere. So जो भी हम देखते हैं as collisions, interactions, volcanism, earthquakes are because of these type of interactions. Yes, Aryan, absolutely. The mantle is predominantly a solid. Okay, but parts of mantle can be molten. I'll come toward this afterwards. The mantle is capable of melting and circulating. Okay, the mantle can move, but not the entire mantle. So agar ye this is the crust, say continent here, say ocean here, say continent here, say ocean here, and say this is the mantle here. Okay, and this is the lithospheric layer. Then ये mantle जो है, it can melt and start circulating. It can start moving like this. It can melt from here and then start circulating like this. It can melt at any part. So पूरा mantle solid है, but parts of this. So ये एक pipe बन जाएगा, a conduit, a passage in which the mantle can circulate. But this is solid probably. So the whole mantle is not molten. Parts of it are molten. Yeah, Avinash, come back on this. So this is what ultimately will become the basis of why we have volcanoes, why we have earthquakes, how mountains are formed, and a whole range of tectonic events and tectonic landforms. Okay, so any questions to clarify on this? Anybody? Olivine is found deep in the mantle, not on the ocean floor. Olivine is astronosphere. Okay, part of upper mantle. Olivine is in the mantle. It is not in the oceans. Okay, oceans may you have amphibole and pyroxene. Okay, and olivine is predominantly inside the astronosphere. So that's fine. And you go down and go down, there are other forms of olivine. Olivine, okay, के अलग-अलग forms हैं. Is something like, I mean, not a good example, but maybe to understand this, like carbon. Carbon के अलग-अलग forms हैं ना. We call in chemistry, we call it as allotropes. Okay, we have got carbon graphite, एक allotrope है. Carbon diamond is allotropes. वैसे carbon के अलग-अलग forms हैं. So think of something like that. Okay, so olivine, there are other forms of olivine, some of which I mentioned. ठीक है. You also have garnet. Garnet, if you know about the garnet stone, उसके भी forms हैं deep inside. Can we say Conrad separates felsic and mafic? Yes, you can, but then say relatively mafic. Okay. Hemant, Conrad separates the upper felsic from the lower relatively mafic rocks. Okay, don't just say felsic and mafic. Rapiti, just a layer, उसमें और कुछ मुझे पता नहीं है. Okay, rapiti is a layer at depth of 700-900 kilometers. That kind of separates the middle mantle from the inner mantle. That's all. Don't go. And I told one fact that some of the scholars dispute कि शायद rapiti है ही नहीं. Why? Because the gradation is not as sharp. That's all, nothing more than that. Mechanical and chemical समझ में नहीं आया, तो यश आप रट्टा मारो. Okay, जितना समझाना समझा दिया मैंने. Go back, revise, memorize. Give yourself a couple of days time. You come back again, you will remember. ठीक है? So nothing more than this. I said mechanical is about hardness. Okay, and chemical is about what is it made up of. Of course, these two are related. Whatever hardness I have is related to what is it made up of. But यहाँ पर I talk in terms of कितना hard है, टूटा है या नहीं है या soft है. Okay, and here I talk about what minerals, what composition, what elements. That's all. ठीक है? Anybody else offline? Any doubts? Any doubts? So I think 2-3 of you have joined me today. I have just taken effectively 1.5 class where I have initiated the concept of interiors of Earth. Almost 90% is overlap with GS content, not much of exclusive geography optional. Take the notes, read through. All the notes get uploaded after the class on the portal. All the offline students, you also have access to the portal. हमें जो भी अपलोड करना होता है, शेयर करना होता है, put it on the portal. So make sure you can access it. अगर नहीं हो पा रहा है, go and talk to the support staff downstairs. रितेश होंगे या फिर बशीर होंगे, who can tell you how to log in and access. ठीक है? So read all of that. You have a doubt, come and ask me. I'll clarify. Yes, Charu. Perovskite and spinel are in the mantle. In fact, perovskite is the most abundant mineral of the mantle. Okay. So perovskite is a form of olivine itself, but it is the most abundant mineral of the mantle. Yes, the only found in the mantle. Yes, they can come out. I'm not saying no, but that's very rare. He's asking me, is it possible for olivine rocks, olivine minerals, bahar aa jaye on the surface? Yes, it's possible, but it's not as common. And when we have that, we have a special type of rocks formation. Okay, so yes, we'll talk about this when discussing some bit of volcanism. We do have volcanism coming from the deep mantle also. Crust, mantle, core have different age. What was that, Aryan? You're saying they are made at different times. Yes, absolutely. When the gravity collapse was happening, the core must have formed first. Yes. अब उसे क्या time है? I don't know. I do not know about it. Ophiolite, Indranil, क्या पढ़ रहे हो? Okay. This is not a word linked to what I'm discussing right now. Indranil, hold on, please. Don't ask random questions. Okay, then I can't answer. No, olivine is not always ophiolite. Ophiolite is one type of formations. So don't confuse like that. I'll talk about when I come towards mountain building maybe. Recently, perovskite solar cells in news. I have not heard about it. I must look up. Agar wahi hai, to maybe they're same. I do not know, Mohit. I must look this up. Okay, I think आपके doubts clear हो गए, आप curiosity वाले doubts हैं. So I'm moving on. So now the next topic for discussion is evidences of the Earth's interiors. Evidences of the Earth's interiors. One suggestion to all of you, okay? Let us all accept one thing, that for all of us, or at least most of us, lot of topics I will teach will be new topics. Or new topics mein, it will take time for you to understand, for the concepts to crystallize, for the ideas to sink in. आप इसको force नहीं कर सकते beyond a point. Your work is come to class, आप सुने conversations, make your notes, make a summary. Try understanding. And there are some areas जो मैं समझा नहीं रहा, I'm just saying accept it, that's all. Olivine है तो है, इसमें why क्या है इसमें? Continents are thick, they are thick, that's all. We stop there. You accept it and you memorize it. Okay, because see, we are not studying to become geography scholars. Okay, it's actually unfortunate. एकदम वो ना मतलबी पढ़ाई है. Okay, जो पढ़ाई करेंगे मार्क्स आएगा कि नहीं, उसके आगे ज्ञान हमें नहीं चाहिए. Okay, and that's how our system runs, unfortunately. So I have to draw a line where I will say कि इसके beyond I do not know and we do not need it sometimes. Sometimes I might know, but I will not tell you because I don't want you getting messed up there. We'll draw a line there. Okay? You just move with me. Out of 10 things I teach you, 2-3 ऐसा होगा for which I won't explain at all. We accept that and move on. And believe me, give yourself time of couple of readings, revisions, lot of which were tricky, आपको समझ में आ जाएगा. ठीक है? That's one. Number 2, the best time to ask a doubt is, एक बार पढ़ लो, make your own efforts and then come and ask me. I don't stop you from asking doubts. आप पूछें doubts, it's my prerogative. मैंने ऐसा करना है, नहीं करना है. In most cases, I take up your doubts. But the right doubt is when you go back to your room, you think about what has been taught, make your notes, and then ask your doubts. Then you'll realize that the levels of questions you engage me with, okay, are much better than the earlier type of questions. In fact, your doubts tell me आप कितने पढ़ाई कर रहे हैं. Your doubts tell me आप focused हैं या नहीं हैं. Okay, so don't trivialize own efforts also. Okay, अभी doubt है, अभी बता दो. Okay, it doesn't help generally. Go back to your room, open the notes, दोबारा पढ़ो. Whatever is worth knowing, I'm making you write more or less. The next day is the best time to ask and clarify your doubts. Impulsive doubts is generally I discourage. Impulsive doubts are those, okay, आपने सोचा नहीं, फटाक से पूछ दिया. Okay, and if you listen to doubts of each other, you will know which of the doubts are impulsive doubts. ठीक है? So be patient there. We all will get hang of this eventually. Okay, let's get on. Evidences of Earth's interior. So the fact is, जो Earth's का radius है, the Earth's radius is about 6,400 kilometers. And if you look at our drilling projects, if you look at explorations of the Earth, in most cases, we have reached about 10 to 15 kilometers, okay, inside from the surface. In fact, China has a couple of experiments going on. They are drilling holes and whatever they're doing. So हमें डर लगता है कि पता नहीं खोद खाद के पता लगे कि हमारी तरफ ही निकल आए बाद में. Okay, आएंगे तो we'll surprise them. Don't worry. Okay, बाहर निकलेंगे from the hole and we'll do this. Okay, so they do some experiments, but the maximum we have gone inside is about 10 to 15 kilometers. Most of these are the deep oil and gas wells. Okay, which means we have just about scratched the surface of the earth. Okay, so Earth's radius is this much. Our drilling projects, okay, our explorations of interiors, the maximum we have drilled inside is just about 10 to 15 kilometers from the surface of the earth. So our point of conversation is that to physically reach and study the interiors is impossible. Okay, so we can't go down there and study what the core is, study what the mantle is. We can't do that. To physically reach and study the interiors is almost impossible. So the study of interiors is done by other means. The study of interiors is done by other means. हम बाकी तरीके से पढ़ते हैं कि अंदर क्या होगा. So one of the students asked me, so is it possible lot of what we know inside about the earth are mere speculations? I say no. Maybe we are not very sure about some things, but by and large what we know is not wrong. It is not guesswork. It is mathematical study analysis, spectroscopic analysis. They have found ways how to study some of the waves coming from interiors. The interior study is not speculative guesswork anymore. The point here is what we know is not completely wrong, but does not mean we know everything. हमें कुछ ना कुछ नया discover होता ही है. Like this year we discovered that the core probably has a third layer also. So those type of discoveries happen. But the interiors, even if we can't physically go and see there, it does not mean what we know about the interiors are mere guesswork and mere speculations. Ye fantasy hai, no, it's not. It's well scientific established. Okay, the study of interiors is therefore done by other means. Other means mein kya hai? Okay, we study the rocks and the sediments sourced at mines, sourced at oil wells. ये भी बताते हैं कुछ ना कुछ हमें. You have got sediments coming out from the Earth's interiors when you are mining, when you are drilling. Okay, so we study rocks and sediments that are sourced at the mines and sourced at the locations of the oil wells. Okay, in fact, जो mines होते हैं, where you go inside, the deepest mines are about 3.5, 4 kilometers deep. Uske beyond, physically, man has not gone inside as conveniently. Yes, correct. The mines, the gold mines in parts of Karnataka, they are among the very deep mines. We have heard about Kolar gold fields, right? Kolar gold fields, the Hatti gold fields, they काफी deep mines हैं. Okay, we have some of the diamond mines in parts of South Africa. They again are very deep mines. But वो deep होकर भी, they're about 2.5, 1 kilometer deep. Okay, parts of it might go even deeper. उससे ज़्यादा नहीं होगा. Anyways, but that's nevertheless a source of some knowledge. We study the volcanic rocks. Okay, the volcanic rocks, they come from deep inside. The volcanic rocks and volcanic pyroclast. Pyroclast is all the sediments that come out with the volcanism. It can include the volcanic dust. It can include the broken rocks, the fragments of rocks. Okay, we call that together as pyroclast. All the sediments that come out in volcanic eruptions are called as pyroclast. The study of volcanic rocks and the study of pyroclast. ये भी कुछ बताता है हमें insight के बारे में. Third is by studying meteorites. By studying meteorites. See, at the end of the day, Earth was formed more or less by the same process that created all the other bodies of the space. ठीक है, Earth unique है, but the process of formation is not dramatically different from how others were created. So if I know how maybe Jupiter was formed, how Saturn was formed, how the asteroids were formed, I can infer about how Earth might have been formed and what does Earth have. Ultimately, all the matter we have on the Earth is part of the space. What makes Earth unique is more about how the processes combine together to have what we have. But we have evidences that other planets में भी शायद पानी था. Other planets probably also had maybe some gases which Earth has. आज के date में Earth does not have much of helium, but there was a time when Earth was predominantly helium. Why? Because helium is the most common gas of the space. So we are correlating. Okay, that if I study meteorites, what are these? They essentially are rocks. These are stones, okay, that crash on the Earth's surface. Okay, so by studying those meteorites, I can know कि Earth का भी ऐसे ही कुछ composition होगा. Okay, so not a great way of knowing the whole Earth, but nevertheless, this is credible source of knowing what we know about the Earth. अच्छा, इसके अलावा there are some parts of the Earth where there are very deep valleys and cracks. There's a term called as trench. इस term सुना होगा आपने? If this is an ocean, this is another ocean, and there are some gaps between the oceans because of subduction. ये gap को बोलते हैं trench. So those who do not know the word trench, hold on. 2 दिन पता चल जाएगा what it is. Others, okay, trench is a gap on the lithosphere. Okay, and the gaps can be very deep. In some parts, they can be as deep as 10, 12, 15 kilometers, even more for that matter. Okay, so if you know about the trench called as Mariana Trench. Mariana Trench is in the Pacific Ocean, and वहां पर एक very deep part है called as the Challenger Deep. The Challenger Deep is 12 kilometers deep. Okay, so there are some locations on the Earth where the trenches are very deep, and we can see parts of the mantle. एक trench है Southern Atlantic Ocean में called as the South Sandwich Trench. South Sandwich Trench in the Southern Atlantic Ocean. If this is the Atlantic Ocean, South America, that's equator, Africa. Okay, so somewhere here we have a trench here. This is called as the South Sandwich Trench. और ये काफी deep है, not as deep as Mariana, but काफी deep है. And at this trench, parts of mantle are visible. When I say visible, I do not mean I can see with naked eye. I can use some instruments and I can know कि वहां पर mantle है. Okay, वैसे Mariana Trench. Mariana Trench is in the Pacific Ocean. A trench called as Mariana Trench. Okay, at Mariana Trenches, at South Sandwich Trench, parts of mantle are accessible. Okay, that's all. You don't need no more than this. South Sandwich Trench. Okay, so study of the exposed mantle at deep trench locations, such as I said, the South Sandwich Trench, and also at Mariana Trench. Okay? So how do I know about those interiors? Although I cannot physically go and see the mantle and the crust, nevertheless, we can access and study in different ways. Okay, 4, 5 बता दिया आपको मैंने. Okay, study at the mines, study of volcanic rocks, study of meteorites, and study of the exposed parts of mantle at the locations of the deep trenches. Okay, so this you understand. Then we have another set, okay, of studies. There are gravity studies. Okay, there are density studies, and there are seismic wave studies. Difference क्या है? There are gravity studies. The gravity studies, there are density studies, and there are seismic earthquake waves, seismic wave studies. Difference क्या है? In this study, we are studying some material which we can collect, we can physically see, we can observe in some instrument. Okay, so this looks more like a direct thing. These are all mathematical studies. Okay, आप waves record कर रहे हैं, आप energy record कर रहे हैं, and then you're inferring. So these studies are otherwise referred to as indirect studies. They're more of mathematical extrapolations and mathematical conclusions. Mathematical conclusion. In fact, these techniques, इससे compare करें ना, these are more reliable because they fit into some kind of patterns which they can infer. The much of what we know about the space also is this study. They do spectroscopic study, energy देख रहे हैं, radiations देख रहे हैं, and then they conclude what they conclude. ARIA, no, we don't add that into this studies. Okay, so not much to know on this. Ultimately, what is gravity? Gravity is the force of attraction, and it is a property of that body and its mass. जहां पर ज्यादा mass होगा, I'll have more gravity. जहां पर कम mass है, I'll have less gravity. That's one way of knowing in which part of Earth has more mass, more density. Okay, so they do some calculations and they know it. Think of density. For example, Earth's surface density is about 2, 2.5, and 3. Whereas I know that the Earth's total density average is 5, 5.5, which means agar surface pe 2, 2.5 hai, as I go down, it must be more dense. As example of density studies, I'm inferring. Earth spins, and Earth ka spinning is not random spinning. It's a very smooth spin. Smooth spin is not possible if the mass is not evenly distributed. Think of a body where this has density 10, this has density 5, this has 1, this has probably 15 density. और इसको अगर आप spin कराओगे, it'll be a very wobbly spin. It'll not be a smooth spin. Because Earth is spinning so smoothly, every possibility कि अगर 10 है तो 10 will be evenly distributed. जब ये smooth बनेगा. अगर 15 है, the 15 is evenly distributed. अगर 5 है, the 5 is a part of a concentric sphere. So this is how we infer, okay, that how the Earth's layers, okay, are not random. There's a pattern to this. Okay, so in your notes you don't need all of this. You just know that there is a gravity studies, there are density studies. Our main focus is this one. इससे सवाल आती हैं. Okay, this is part of your syllabus. Questions आते हैं, and I'll go deep on this. I'll ignore all of this for now. Okay, so how do we know about the interiors? We have other ways, not direct access. We have these 4 methods, and we have these 3 indirect methods. Okay? Yeah, please ignore. Nothing to add here. Okay, focus on this one. So give a heading, a seismic or earthquake evidences of Earth's interiors. Some of you would have done GS by now, and so this is part of GS also. In fact, good part of physical geography has a very good overlap with your GS studies also. So padha achhi baat hai, you only confirm. You can check whether I know the subject or not. Okay. और मुझे doubt होगा तो आपको पूछ लूंगा. Okay. So those who know this, very nice. Patiently listen to what I am teaching. Okay. Fine. Now, जो earthquake waves हैं, earthquake waves, they essentially are energy. Whenever we have vibrations, vibrations are essentially energy systems. And these energy systems are of two types. One energy systems are called as radiations. Okay. Radiations are energy forms that travel without the need of a medium. They don't depend on the body and the medium. So what's radiations? Radiations are energy forms that can travel without the need of a medium. Okay. So I'm sure you have heard about gamma rays, you know about X-rays, you know about ultraviolet rays, you know about infrared waves, there are microwaves, there are radio waves. All of these are radiations. Okay. Radiations are energy systems which can travel and they do not require any medium. Light. Light is a tricky thing. Okay. Light has, we say, dual properties. Light particles bhi hain or light radiations bhi hain. So light is not the best example of a wave. Okay. What's Higgs boson? लेकिन क्यों पूछ रहे हैं आप? Anish, जिसने ये पढ़ाया, Higgs boson is a part of earthquakes evidences. Okay, he has taken you for a ride. Higgs boson is what's called as God particle. God particle as in the fundamental particle, which is the fundamental composition of the universe. For a long time, what makes the universe, we have called that as the dark matter. Dark because हमें पता नहीं वो क्या चीज है, but we know वो है. Okay, something or the other is there that makes up whatever makes our universe. So Higgs boson is that. Okay. So आपने क्यों कहा मुझे पता नहीं, but okay, मुझे पता है. Okay. So in case you are testing there, allowed, कोई दिक्कत नहीं, हम भी कर चुके हैं ये काम. ठीक है. So when I was a student also I would test कि पैसे ठीक लगाया कि नहीं लगाया. Okay. जहाँ नहीं पता होगा I'll say कि नहीं पता है. Okay. I'll say out of course या भूल गया हूँ. जो पता है तो पता है. ठीक है. So I win this round. Fine. So radiation. So energy जो आ रहा है, one type of energy are the radiations. Radiations which are types of energy that does not require a medium and they behave in some ways. आप इसको ignore करें for now. And these are examples of radiations. Gamma radiations, X-rays, ultraviolet and so on. Yes, absolutely. We also have one here called as the visible spectrum, which is your Vibgyor, right? Violet, indigo, blue, and so on. It's between ultraviolet and infrared. Okay, this is called as the visible spectrum. Okay. Then there are energy which are mechanical waves. Mechanical waves. Mechanical waves are those where vibrating particles are involved. Okay. इस case में there are no particles, it is energy moving. Yes, I know most of us without a science background, otherwise also science wale bhi, you can't visualize what does an radiation look like. अगर वो particle नहीं है तो क्या है, हम इसको imagine नहीं कर पाते हैं. एक particle vibration is what I can imagine. So it's easy to conceive, it's easy to think about it or picture it. यहाँ करना मुश्किल हो जाता है. Just know it's something moving which we can't see, but we definitely can feel in terms of the impact. Okay, जैसे होता है ना कि emotions हैं, emotions के थोड़ी particles होते हैं. Okay, emotion can create particles. गुस्से से जूता मारा तो that's a particle that you have. But emotion itself has no particles, right? Wind is this. Wind has particles. There's air molecules. इसमें कुछ molecule नहीं होगा. ठीक है? So this is different. No particles. There's no body. It has no weight. It has no dimensions. Energy moving. Okay. Except it कुछ है. And beyond this, अगर doubts हैं तो Swami Nityanand. Okay. He is your answer. You don't know Nityanand. He's a great scholar. Okay. Totally indigenous. Okay. Made in India product है वो. Okay. बाद में बात करेंगे उनके बारे में. ठीक है. He is a different species. I'll talk about him later on. But he is my favorite. Whenever I am sad, upset, whenever I doubt my capabilities, I go and listen to him. Okay. तो आप भी कर सकते हैं. Okay. कुछ ना हो पाया तो कुछ ना कुछ कर ही लेंगे. Okay. So mechanical waves are vibrating particles, the particles that move. Mechanical waves, because they have particles, these energy waves, they require a medium to travel. They require medium to propagate. Okay. And therefore the properties of the waves are related to the properties of the medium. This is the most important statement for this conversation. That the mechanical waves are essentially vibrating particles. ये particles हैं जो move कर रहे हैं. And as they move, the energy starts to get transferred. And because they require a medium to move, how the particle behaves, how the energy moves, with what property, what speed, what direction, how it changes, whether reflection, whether refraction, they become fast, they become slow. Is a property of the waves hai, the property of the energy hai, the property depends on the property of the medium. Okay, so the property of the waves, the properties of the traveling energy is correlated with the properties of the medium. और एकदम one-on-one correlationship है. Okay, I exactly know अगर X type का property है means the medium is A type. अगर Y type का property है, I know the medium is the B type. If I know that the medium is C type, it definitely will have, okay, maybe a Z type of property. ये दोनों related है, one-on-one perfect correspondence है. ठीक है? So the property of the waves are correlated with the properties of the medium. It basically means the speed of the energy waves, head down. The speed of the energy waves, the path of the energy, the speed of the energy waves, and the path of the energy waves depends on the nature of the medium through which they propagate. Depends on the nature of the medium through which they propagate. which implies if we can record how the waves behave, which implies if we can record how the waves behave, we can infer the nature of the medium through which they pass. We can infer the nature of the medium through which they pass. ठीक है? Like if I know A, I can tell this. If I know this, I can tell this. They are perfectly correlated. That's how we know the interiors of the Earth. So we have some devices which can record the energy coming out because of earthquakes. And by recording how the waves behave, I can tell कि किस depth में what type of rocks are present. How they do this, that's beyond our scope. There are instruments. Let's not question that part. So how are the radiations captured? We know there are devices. Universe studies में we know there are devices, there are telescopes there. So वैसे ही कुछ instruments हैं. Okay, so this is the fundamental principle of how and why the seismic waves are the basis of knowing the Earth's interiors. And on this point here, this correlation between the wave property and the medium is so perfect. The correlation between the wave property and the medium is so perfect that seismic studies are like confirmatory studies. Seismic studies are like confirmatory studies of the Earth's interiors. Yes, correct, Ranjan. Is only true for mechanical waves, because mechanical waves require medium, not the radiations. Check, all done here? So I've given the principle of why we use the seismic waves to know about the interiors. Next, ये जो seismic mechanical waves हैं, they are of two types. They are surface waves and they are body waves. There are two types on the basis of location, where they are moving. Seismic waves can be surface waves, they move on the surface, or they can be body waves. So surface waves, agar yahan earthquake hai, the energy is moving along the surface. Agar ye body hai, the energy is moving through the body. So I need to study both, but more important will be the study of the body wave, because मुझे जानना है अर्थ के अंदर क्या है, rather than surface तो चलो हम जान ही लेंगे more or less, but I need to study this more. That's one. Then the seismic mechanical waves, on the basis of their properties and particles vibration, they are of two types. In terms of location where they are, they can be surface waves, they can be body waves. On the basis of the wave properties, on the basis of the particles vibration, they are of two types. They can be transverse waves. We also call these as secondary waves, or they're called as S waves, or they can be longitudinal waves. also called as primary waves, or they are called as the P waves. इस पे क्वेश्चन था इस बार in the prelims this year. There are something on this question. Okay, the seismic waves in terms of how the particles vibrate. Okay, there are two types. They can be transverse waves, also called as secondary waves, or called as S waves in short, or they can be longitudinal waves, also called as primary waves or P waves in short. इन दोनों का प्रॉपर्टीज अलग होता है. S waves में क्या है? The particles are vibrating at 90 degrees to the energy path. In this, the particles vibrate perpendicular. Transverse means perpendicular. The particles are vibrating perpendicular to the direction of energy transfer. Perpendicular to the direction of energy transfer. Essentially, if energy ऐसे move कर रहा है, the particle is vibrating at 90 degrees like this. Imagine this is 90 degrees like this one. The energy is moving like this. Okay, either this or even this. ये भी 90 degrees होगा ना? It can be in the vertical plane or they can be in the horizontal plane. Okay, the particles vibrate like this and the energy moves like this. Typical example of this is, think of when you plug the guitar string. आपने plug यहाँ पर किया. Okay, you are plugging here. It moves here, but you can see the waves like the traveling along the string. The particles vibrate at 90 degrees to the moving energy. And in this case, the particles vibrate along the axis of the energy propagation. This is perpendicular to the axis or the direction of movement. This is along the axis of the energy propagation. If I draw this diagram, अगर ये energy जा रहा है, the particles are vibrating up and down. The particles are vibrating up and down like this. In this case, अगर ये energy है, the particles are vibrating along the axis of the energy travel. Okay, the particles are moving like this. Okay, and energy is moving ahead. Energy moves ahead. The particles are moving like this. Okay, in this case, the particles are moving at 90 degrees. The energy is moving like this. ये ज़्यादा smart है. Is it Hrithik Roshan, no? Okay, he moves like this. Guitar and tabla. Well, whatever is the analogy. Okay. P waves, these are in general faster. Okay, than these waves. Example of this wave is sound waves. Sound waves are examples of longitudinal waves. इस केस में the particles have a crest and a trough. A crest and a trough. In this case, we say the particles have a rare fraction. They come close and they move away. Okay, this is, sorry, they have compressions and they have rare fractions. They come together, they move away. They come together, they move away. इसमें is a crest and a trough. A crest and a trough. ठीक है, fine. I think this much will do. You don't have to go beyond this. ठीक है. So these are the two type of waves we have, mechanical waves. Okay. Now I'll discuss a bit more on this. So we have the S waves and we have the P waves. Both are examples of mechanical waves. Both are because of the particles actually vibrating. Okay. S waves, I said, are relatively slower. The P waves are relatively faster. S waves can move only in rigid mediums. They can move only in solids. In general, all other factors remaining the same, the S waves are slow waves. ये पूछा हुआ क्वेश्चन था प्रीलिम्स में. And the P waves move at faster speed. Then I said S waves can only move in medium that is rigid, means which is hard. Okay, any solid will do. They cannot move through gases. They cannot move through liquids. Okay, because they can't vibrate anymore. They can't move through gases. They can't move through liquids. Whereas the P waves, they can move in any state of matter. They can move through solids, they can move through liquids, and they can also move through gases. Through solids, through liquids, and through the gases. The sound जो है, sound can travel in air. Sound can also travel in water. And sound can also travel through any solid. Like iron bar hai, if you speak something here, you can hear the sound reaching you along the iron bar or iron rod. So this is only in solids, but this can move in all the three mediums. Okay. And for both of them, the velocity is positively correlated with the density of the medium. Okay. अगर मीडियम का ज्यादा डेंसिटी है, the speed is more. So solid, imagine solid is say a block of iron and a block of aluminium. Okay, S wave will move fast in iron and slow is aluminium. P wave also is fast in iron and slow in aluminium. And there is a tank of maybe water. Water S waves में pass नहीं करेगा. Okay, P wave can pass, but the velocity will be less than iron or aluminium. Or think of a back box with only gas. इसमें S wave नहीं होगा, इसमें भी S wave नहीं होगा, इसमें तो P wave होगा, it will be the slowest. ठीक है? So the velocity of both P and S waves depends on the density of the medium. The velocity is positively correlated. का मतलब है, okay, अगर बढ़ेगा density, the velocity will increase. If the density is less, the velocity will fall down. Aryan, example यही है. एक iron rod है, एक aluminium rod है, a tank of water है, and maybe a flask of some air. Okay. The P wave velocity. The P wave velocity in iron, the P wave velocity in aluminium, the P wave velocity of water, and the P wave in the air. So P iron ka velocity is more than, aluminium is more than, water is more than the air. In case of S waves, same thing. S wave also, velocity in iron is more than that of aluminium, but S waves cannot travel in the liquids, they can't travel in the air. That's about it. Okay. So this is the property that we must know. Okay. And then we infer about how the earthquake waves are behaving and what does it tell us about the interiors of the earth. All of this conversation you will not need in your answers. Answer may we just need a small description of the principle. The principle is that the Earth's interiors can be known objectively by studying seismic waves. Second point, because the property of seismic waves are related to the medium's nature, therefore, by knowing how the waves behave, we can know about the interiors. That's all. And maybe in a small box, P waves can pass through solids, liquid gases, S cannot. And in terms of velocity, it increases as the density increases. That's all. In the answers, the answer लिखेंगे आप, we do not need all the details. All we need to know is that seismic waves, of course, the mechanical ones. The seismic waves are confirmatory evidence of the Earth's interiors. Okay, because seismic waves properties are related to that of the medium they travel through. Okay, a study of the waves behavior, okay, helps understanding the nature of the layers inside the earth. बस आपको यही दो सेंटेंस चाहिए. The rest is for you to understand, for you to decipher whatever ultimately you observe. Mechanical waves means they require medium. Yes, correct, Hemant. Yes, mechanical means something is moving, no? What's moving? What's vibrating? The particles, correct. Yes, Hemant. How two completely different sets of waves can originate from common event? The energy coming out depends on many factors, Satyam. It's not only one event. Okay, and all of them together can give us a range. Think of a light source, no? How can the same source give us so many different type of lights? हमको white दिखता है, actually has 7 lights, no, and even more probably. That's how. Any example of S waves? Any vibration of a string, Tushar, is an S wave. Any vibration of a string is an S wave. Yes. Because seismic waves, okay, because seismic waves properties are related to that of, likho, because seismic waves properties are related to that of the medium through which they travel. Because seismic waves properties are related to that of the medium through which they travel. Study of the waves, okay, or waves behavior. The study of the waves behavior helps understanding the nature of the layers. Helps understanding the nature of the layers of the interiors of the earth. The layers of the interiors of the earth. All done here? आपको आंसर में बस ये दो चाहिए. And at the max, what you can do if your space and time permits is, you can always mention some bullets. Okay. S waves. These are transverse waves. Only pass through solids. P waves, longitudinal waves can pass through any medium. Both S and P waves, the velocities are proportional to the density of the medium. Proportional to density of medium. इसमें एक और ऐड कर दो. Okay, लिख लो please all of you. I've done it. I'm only repeating it. That's all. जो आपने लिखा था 2 पेज में, मैंने खत्म किया आधा पेज में. As a summary, that's all. So S waves are transverse waves. They can pass through only solids. P waves are longitudinal waves, can pass through any medium. Okay. But for both S and P waves, the velocities are directly or positively correlated with the density of the medium and with a rigidity of the medium. The velocity is correlated with both the density and the rigidity. Zyada hard hoga, the speed is more. Soft hoga, speed is less. Zyada dense hoga, speed is more. Less dense, the speed is less. So in physics, density is this and rigidity is this. So there is a positive correlationship of velocity with density and of velocity with rigidity. This is the sign of rigidity. This is sign of density. You may not know this, that's okay. I want these 3 statements, that's all. Now, if I ask you, all of you listen, if I ask you, can the S waves pass through continents, yes or no? Yes. Can the P waves pass through continents? Yes. Can the S waves pass through molten magma? No. Can the P waves pass through molten magma? Yes. Can the S waves pass through the outer core? No. Why? Because outer core is liquid. Can the P waves pass through outer core? Yes. When both P and S waves are moving, okay, will the speed be more in the continents or will it be more, okay, on the oceans? Ocean water nahi, ocean rocks ki baat kar rahe hain. Until I go into oceanography, whenever I say oceans, I mean the ocean floor. I mean the ocean rocks. So both P and S waves, and they're moving, okay, continent rocks be solid hai, oceans be solid hai, right? When they move, in which case will they be faster? The ocean rocks. Why? Because oceans are denser. Okay, Shravanveer, कल से आप ठीक सारा उल्टा आंसर दे रहे हो. ठीक है? So your solution is आपको जो मन में आए उसका उल्टा लिखना. ठीक है? मन का कुछ नहीं कर सकते हैं. Okay, you said something else. Fine. Yes, oceans are basalt. Remember? Oceans are mafic. Oceans will have higher density. So when the P and S waves move, they are faster in the ocean rocks. They are slower in the rocks of the continent. Inside the continent, watch here again. Inside the continent, when both P and S waves are moving, will the speed increase or decrease? Why will the speed increase? Because upper parts are felsic rocks. As they go down, they become more and more, relatively more mafic rocks. Okay. So when they cross the Conrad discontinuity, kya hoga? They'll become faster. Upper layers are less dense. Lower layers are more dense. Is it okay, all of you? Achha, now, when the P and S waves are moving, okay, from the crust into the astronosphere, what will happen? Will the speed become less or more? When the waves are moving, okay, when the waves are moving from the lithosphere into the astronosphere, what will happen? Astronosphere, watch it. Astronosphere is more dense or less dense? Astronosphere is more dense or less dense? Astronosphere is more dense. The average astronosphere is around 4. Zyada dense hai. But it is, okay, semi-molten. It is less rigid. I hope you got the point here. So यहाँ पर, okay, डॉक्टर साहब फंस जाएंगे. This is the lithosphere. Okay, and this is the astronosphere. Okay, the lithosphere is continents and the oceans. Astronosphere is the mantle. Okay, this is more dense. This is relatively less dense. ये 2.5 है, अगर oceans है तो 3.5 है. Whereas astronosphere is approximately around 4 or 4.5, more dense hai. Okay. If I go by density, if the P and the S waves are moving, what will happen? Will they become slow or fast here? Will they become slow or fast? Okay. But एक और point भी है. Lithosphere is harder. It is more rigid. Astronosphere is, okay, is, the word is semi-molten. It is less rigid. If you go by rigidity, okay, the speed will become less. तो होता है क्या actually बताओ फिर? If I go by density, the speed becomes very high. If I go by rigidity, the speed becomes less. तो actually क्या होता है? बढ़ता है या घटता है? Now see, this is an example of two factors influencing something. And to know which factor dominates, you must know the actual equation, which we will bypass. ठीक है? It's like, आपको जब देखता हूं तो बहुत प्यार आता है, लेकिन जब आपके बापू के बारे में सोचता हूं, okay, तब घबराहट होता है. तो एक्चुअली होता क्या है? It all depends on, okay, क्या circumstances हैं. ठीक है? There are both factors are there. आपका चेहरा भी है और आपके और मेरे फ्यूचर ससुर जी भी हैं. So what will impact me is a matter of circumstances. You can't make an equation without knowing the details. So in Earth's case, both are important. Density भी important है and rigidity भी important है. But where what will impact is not for you to guess. They have done the work, they have studied, found equations, and they have found out that when the P and the S waves are moving into the astronosphere, the net impact is their speed increases. The speed increases, however, okay, not as much because the astronosphere is, okay, a less rigid medium. जितना बढ़ना चाहिए उतना बढ़ता नहीं है, थोड़ा सा कम बढ़ता है. Is it okay, all of you here? So if I see you and your father together, प्यार आता तो है लेकिन इतना भी नहीं आता है. अब ठीक है? Okay? Yes. So, you have two factors and you can have multiple factors. Okay. You can have other factors in terms of, okay, maybe whether it is hot or it is cold, वो भी एक factor है. It can also matter if the pressure is high or low, वो भी एक factor है. But net, this is what is happening. So as waves do travel, yes. Now, Pranjal, मैंने कल बताया था. Though I say semi-molten, it is a solid. Semi-molten because I do not have another word for it. In English language, I have not found a word which can best explain the nature and the rigidity of the astronosphere. So semi-molten is a compulsion for me. मेरे पास वर्ड नहीं है तो मैं कह रहा हूं कि सेमी मोल्टन है. But please do not see astronosphere as a liquid medium. It is solid but capable of deformations under sustained pressure. Okay, all of you here? आपको क्या करना है? You must describe how the changes happen. कैसे change हो रहा है is what you will describe, and that's good enough. Okay, so write one short paragraph here. Okay, give a subheading. Give a subheading. The behavior of P and S waves, the behavior of P and S waves as they travel through the Earth's interiors. The behavior of P and S waves as they travel through the Earth's interiors. To the Earth's interiors. This is the actual answer that you need. Okay. So first point here, the first point, all earthquake waves, okay, can be sourced from any part of the Earth's interiors. All earthquake waves can be sourced from any part of the Earth's interiors. कहीं से भी आ सकता है. The earthquake can be anywhere, near the surface, in the mantle, deep mantle, कहीं भी हो सकता है. Next, what are more considered are those that are near the Earth's surface. Okay, so imagine here, ये Earth है, Earth here. I can have an earthquake here, I can have an earthquake here, I can have an earthquake here. This earthquake waves travels like this. The waves can travel like this. They can go in any direction. But convenient होता है कि let me assume that I have only earthquake near the surface. ताकि यहाँ से if I study, I can know the proper pattern of how the rocks are behaving. Okay, so in studies we can take up any one of this. जैसे कि आपके पढ़ाई कर रहे हैं, मैं तो कहीं शुरू कर सकता हूं पढ़ाई आपका. But there is a logical way. The logical way is, let's ignore all of these earthquakes. Let's take up that earthquake जो कि surface के पास है, so that when they travel, I can know the entire path through which they are moving inside the interiors of the earth. So that's why the diagram are generally those drawn for this type of earthquake and not for this type of earthquake. हालांकि ये गलत नहीं, you can do that if you want to do that. Write down. Within bracket mention, therefore, shallow earthquake foci are more commonly considered. Shallow earthquake foci, or sorry, it should have been a shallow foci earthquake. Shallow focus. I interchanged the location. Okay. Shallow foci earthquakes are generally considered for earthquake studies. Shallow focus का मतलब है depth कम है for earthquake studies. 1 point. The next one, the P and the S waves, they move as sets. The P and the S waves, they move as a set. And their behaviors are tracked. So when the waves are moving, okay, so the waves come out together. P wave and S wave, दोनों साथ निकलते हैं. This is one set. In this one set, the P waves goes fast, the S waves goes slow. The next set, again the P waves goes fast, the S waves go slow. So you always study in terms of PS set of waves as they start off from the earthquake focus. Next point. Yes. Repeat. अब एग्जैक्ट वर्ड तो मुझे याद नहीं रहेगा बिकॉज रटा नहीं मारा था मैंने. आपने क्या लिखा बताओ? P and S waves move or emanate as sets. They emerge as one set. ठीक है? से P अलग जाएगा, S अलग ऐसे नहीं होता है. When they come out as a set together, in which the P waves moves faster and the S wave moves slower. ठीक है? लिखा आपने? अपने शब्दों में लिख लो ना, अंग्रेजी तो है और क्या है इसमें. The study of earthquake कैसे होता है? The P and the S waves, they emerge as a set of earthquake waves, in which the P wave moves faster and the S wave moves relatively slow. Okay, right, next point. Initially, the P and the S waves have lesser velocities. The P and the S waves have lesser velocities. Within bracket लिखो आप, less than 5 kilometers per second. Less than 5 kilometers per second. This corresponds to the upper felsic or granitic layers of continents. It corresponds to the upper felsic or the granitic layers of the continents. So think of this as the continent, and this is the Earth's interiors below the continent. Okay. This is the Conrad layer. तो यहां पर जो P wave और S waves हैं, these are very slow. Okay, they're very slow. The velocity is less than 5 kilometers per second. ये vary करता है. For S wave, it can be as less as 3.5, 3.7. The P wave can be 4.5, 4.7. That's okay. We generalize this. Less than 5 kilometers per second. And this corresponds to the upper granitic layers. And therefore, the waves are called as PG and SG waves. G as in granite. Okay. The top set is called as the PG and SG, okay, waves. PG, SG waves. Okay. Then after about 15 kilometers depth, after about 15 kilometers depth, क्या होगा यहां पर फिर? There will be sudden increase of velocity. Kilometer depth, this is corresponding with, after about 15 kilometers depth, corresponding with Conrad's discontinuity. Corresponding with Conrad's discontinuity, the velocity of P and S waves progressively increases. The velocity of the P and S waves, it progressively increases. Okay. The velocity averages around 6 kilometers per second. The velocity is average around 6 kilometers per second. Okay? It means it is now entering continents ka, the denser part. The upper part is felsic, granitic, जो हल्का है. यहाँ पर it becomes far more denser. So they pick up speed. Next slide down. Next is, okay, at the Mohs discontinuity. At the Mohs discontinuity. आप बताओ क्या होने वाला है यहाँ पर? What will happen to P and S waves? Will they become fast? Will they become slow? What is Moho? Moho is the boundary between the crust and the mantle. Okay. The speed will suddenly increase. So at the Mohs discontinuity, the P and S waves have a sharp increase of velocity. have a sharp increase in the velocity. Okay, that is the P and S waves enter the mantle, which is very dense. Very dense. The velocities can be around 7 kilometers per second. Sudden increase, the velocity can be around 7 kilometers per second. Next one. After 100 kilometers, 100 क्या हुआ आपका? This is the boundary of the lithosphere. याद आ रहा है? You enter astronosphere. After 100 kilometers, there is an initial drop in the velocity. The initial drop in the velocity from about 7.8 kilometers per second to around 7.3, 7.5 kilometers per second for the P waves, to from about 7.8 kilometers per second से गिरता velocity to about 7.3, 7.5 kilometers per second. ठीक है? अब आप बताते one point here. जो भी values बता रहे हैं ना, all the values are for the P waves. Okay, most books don't mention S waves, so I ignore it. All the velocity waves बता रहे हैं, they are average of the P waves, not of the S waves. They move together, but the S is moving a bit more slowly. So at 100 kilometers depth, the speed suddenly falls down around this point. The fall of the speed is sudden fall in astronosphere's rigidity. Sudden fall in astronosphere's rigidity. ठीक है? हाँ, सही तो है. मैंने कहा था ना, कॉन्टिनेंट्स में कम होगा, एस्ट्रोनॉस्फीयर में ज्यादा होगा, है ना वैसे? Okay. In the continents, the speed is how much? I said 5 approximately. Astronosphere में it's around 7.3, 7.5. I'm comparing from the lithosphere to astronosphere, there's a fall. But if fall होकर भी, the speed in astronosphere is more than the speed in the continents. Sorry? Actual value है, not increase. It's not fall off नहीं है. It falls to. Increase, आप क्यों कह रहे हैं increase होना चाहिए? क्या रीजन है? आप क्यों कह रहे हैं increase होना चाहिए? हाँ, तो इंक्रीज किससे कंपेयर किया मैंने? जब मैंने कहा था इंक्रीज होगा, मैंने कंपेयर किया था विथ कॉन्टिनेंट्स. If I compare the continents and I compare astronosphere is less rigid, but it is more dense. In case of continents and astronosphere, the factor more important is density. But if I compare lithosphere का lower layer, आप ये diagram भूल जा रहे हैं. This is the lithosphere. This is the astronosphere. And somewhere here is, okay, the Moho discontinuity. This is the continent. This is the ocean. This is the upper part of upper mantle. This is the lower part of the upper mantle. This is the astronosphere. अब हम ये कहना चाह रहे हैं कि अगर ये डेंसिटी D1 है, ये डेंसिटी D2 है, ये D3 है, एंड इसका रिजिडिटी से R1 है, इसका से R2 है, इसका R3 है. If I go by density, this is more dense than this. If I go by rigidity, this is less rigid than this. So compared to continent, मैंने पूछा कि बताओ यहाँ पर speed कम होगा कि ज्यादा होगा. Okay, I said if I go by the, I am confused. If I look at density, बढ़ना चाहिए. If I look at rigidity, घटना चाहिए. What I'm saying is, if I compare continent and astronosphere, density matters more. So बढ़ रहा है, यहां पर 5 है तो यहां पर 7 है, 7.3 है. But compare the lithosphere का lower layer and this one. इन दोनों के बीच में the factor more important is rigidity. तो यहां पर 7.8 हिट कर रहा है, जब क्रॉस करेगा यहां पर 7.3 हो जाता है. Okay, all of you here? So you should know what am I comparing. So I said in the astronosphere, as I cross the lithospheric layer, no, Moho is not that boundary. Array, this is not the Moho boundary. This is the Moho boundary. There's no name for the boundary here. I just say it is the margins of the lithosphere. So the P and the S waves, they cross into astronosphere. There is a sudden drop of velocity because of drop in the rigidity. अब ठीक है? Right, next. The P and the S waves, the P and the S waves in the astronosphere, the P and the S waves in the astronosphere have the least velocity, if we compare with the rest of the mantle. If we compare with the rest of the mantle. Make sense, all of you? यहाँ पे कोई problem नहीं है. If I look at the entire mantle, if I look at the entire mantle, आप पूरा mantle उठा लो. Upper mantle, middle mantle, and lower mantle. इसमें density increases and even the rigidity will increase. If I compare the 3 layers, astronosphere, middle and inner mantle, which will have the least speed? Astronosphere. That is why this layer is also called as the low velocity zone. This is only in terms of comparing with the mantle. I'm not comparing with the lithosphere. Okay? So the astronosphere layer, therefore, the astronosphere is also referred to as the low velocity zone. It's also referred to as the low velocity zone. Next, with increasing depth through the mantle, keep writing please. Next point, with increasing depth through the mantle, both the P and the S waves pick up more speed. Both the P and the S waves pick up more speed with velocities more than 8 kilometers per second. Velocity is more than 8 kilometers per second. And I repeat, all the values are for the P waves. Second, and the inner mantle is called as the high velocity zone, HVZ. The inner mantle called as the high velocity zone. How they know the velocity? I said, no, they have methods, they have instruments, how they calculate. That is beyond our scope, we can't handle that. Or kitne depth mein, okay, kitna speed hai? They have some ways of calculating that. How much speed? The speed can touch and cross 8 kilometers per second in the inner mantle. Okay. Now, there's one more discussion here. Now see. We all know that when energy passes through medium of different density, it will not maintain the same direction, it'll start bending. You all know refraction, right? Refraction is what? This is bending. Okay. It's turning. So we know about light. There is water. There is air. ये perpendicular है. Okay. If this is the direction of the light here, what happens in the water? Okay. The light will turn. It should have gone straight. How does it turn? It turns towards the normal. There will be bending. The path will not be straight. Okay. Air density and water density. इसमें क्या है? Air density is less than that of water density. Okay. So the bending is towards the normal. So if I move from less dense towards more dense, turning कैसे होता है? Towards normal. ठीक है? Similarly, when the energy is passing through the layers of the earth, because different layers have different densities, therefore the S and the P waves also bend. Okay, like refraction bends. जैसे light bend करता है, वैसे P and S waves also will bend. देखिए next point है down. Okay, with depth, because there is increase of density. Because there is increase of density, the path of the P and S waves will not be straight. The path of the P and the S waves will not be straight lines. The waves will bend and refract. The waves will bend and refract. Okay, how will they refract? Will they refract inwards or outwards? If I'm moving from less dense towards more dense, how is the bending? Is the bending inwards or is it outwards? Okay. In case of P and S waves, ulta hoga. The bending will be outwards. The P and S waves bend outwards. Bend outwards. Reason? Okay, fine. So what happens is, in case of light, if I assume light is a particle, not a radiation, okay, the speed of light is more in the air than in the water. Okay, so water may the light becomes slow. Because it becomes slow, it compensates by taking a shorter path. Don't write all this down. Let's just know this a bit more common sense type ka, okay? Likhe nahi isko, just know this. So light jo hai, because of less, it's like you're running in a place where there are less people and running in a place where we have got more people. In more people, you become slow. Because you become slow, to compensate for becoming slow, you will take a short path. So light turns inwards because it's taking a shorter path. ठीक है, ताकि speed ultimately maintained रहे. So for light, the speed decreases in a dense medium. But in case of P and S waves, the speed increases in the dense medium. ठीक है, इसीलिए for P and S waves, the bending is outwards, not inwards. The mechanical wave's behavior is not exactly same as how light behaves. Is it okay, all of you here? So, आपको बस नहीं लिखना है that as I go deep inside, the P and the S waves bend, but they bend outwards indicating that there is a progressive increase in the density of the medium. Okay? So put a star mark here, put a star mark. The bending path of the P and S waves, the bending path of the P and S waves is indicative of changing densities of the Earth's layers. Is indicative of the changing densities of the Earth's layers. Okay? The next point. So if you look at the pattern looks like a earthquake wave. They'll not go straight. They'll bend outward, 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 and come out here. They'll bend outwards, 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 and come out here. The P and the S waves, they bend outwards and they keep coming out like this. They keep coming out like this. They keep coming out like this. Until they hit the core. अब यहां पर क्या होगा? Variations होंगे. The S waves will come, they can't travel anymore because outer core is liquid. So beyond this path, I have got no S waves whatsoever because S wave pass ही नहीं कर पा रहा है. So this zone is called as the S shadow zone. Right, next. Right, next. Beyond 104, 105 degrees, beyond 104, 105 degrees, the S wave disappear. The S waves disappear. That is because the S waves cannot propagate through. That's because the S waves cannot propagate through the fluid medium of the outer core. Fluid medium of the outer core. Okay. So what does this angle mean? So आप notes भी इतने लिखना, okay? Answer भी इतने लिखना. For your understanding, if this is the core here, ये center है, okay, and the S waves keep coming. At some angle, they become tangential and they come out here. Okay, if I join this with this, okay, if I join this, this angle is 103, 105 degrees. Okay, which means जहां पर tangent होगा और ये फिर बाहर निकलेगा. Okay, this is measured in terms of what angle it subtends with the center and the vertical axis. So in your books they write down 103 यहाँ लिख देते हैं 103 degrees. In some books 103, in some book 105, 107. That's okay. Don't kill yourself on this data. Okay. On this side also same thing. As they come out, they become tangential here. और ये जो point है, this if I measure from here, this angle is going to be that angle, 103 or 104 or whatever. And they have methods to find out कि अगर ये angle इतना है, so what will be the depth of this अगर ये radius है? ये radius ये भी radius है, correct? They do trigonometry calculations and they know that the tangential होता है at a depth of about 2900 kilometers from the surface of the earth. Write down. From mathematical calculations, it is established that 103, 104 degrees for the S waves corresponds to a depth of 2900 kilometers from the surface. Corresponds to 2900 kilometers from the surface. beyond which the core starts, and the S waves cannot penetrate. Yes, Sauganya, yes. This write-up is like an answer for you. अगर पूछेगा, write a note on the earthquake evidence of the Earth's interiors, आपको यही याद करके उतार आना है, that's all. So I'm giving you like an answer format, 1, 2, 3, 4 points, that's fine. And you draw diagrams, whatever way I'm drawing. Okay? This is for the S waves. Now we have a diagram for the P waves. I'm sure you all of you have known or seen this. So the P waves, again same pattern, they again become tangential here. Okay, this again is 103, 105, whatever degrees on both sides. Uske baad kya hoga? The P waves, now there is inner core, outer core. Now there are some changes. They will bend inwards, they again bend outwards, they again bend like this, and finally they come out here. Because of the variations in the layers, अब यहां पर बहुत सारे changes होंगे. It is no longer a smooth curve straight. Okay, so when the waves come in, okay, they ultimately will come here, they come here, they come here, and so on. And this one is corresponding to 147, 149, 153 degrees, and this is 103, 105 or whatever. So for S waves, ये entire zone था S shadow. For the P waves, not the entire zone. Okay. For the P waves, only this much is the shadow zone. बाकी यहां पर P waves हैं और यहां पर P waves हैं. ठीक है? This is called as the P shadow. And for S waves, the entire arc is the S shadow. Yes, Mohit. Yes, but how they infer that, I do not know. This much write-up is good enough, but your point is right. It is the deflection, kitna turn hua, all of that tells us what is the composition and the nature of those layers. Write down. The P waves have a different set of pattern. The P waves have a different set of pattern, unlike the S waves. Unlike the S waves, the P waves continue to get propagated. The P waves continue to get propagated through the outer core, but after sharp deflection inwards. But after sharp deflection inwards. Inwards क्यों होगा? Remember, ये liquid है ना? In less rigid, they become very slow. The sudden fall of the speed here. Okay. हालांकि ये dense है. This is more dense. This is 9. This is 11. If you remember density. But ये fluid है. Fluid में the speed now becomes very less. So they will now bend inwards. Okay. The P waves finally emerge. The P waves finally emerge at 147, 150, 149 degrees with an associated P shadow, as shown in the diagram, whatever, alongside above, with a P shadow as shown. So one difference is, why do we have an S shadow zone? Because S waves cannot travel at all. Why do I have a P shadow zone? Because the P waves have got refracted. The P waves can travel, but वो shift हो गए. There's a difference between the S shadow and the P shadow right on this point. Therefore, while the S shadow is because, while the S shadow is because the S waves cannot travel through, the S waves cannot travel through the fluid outer core, the P shadow is because the P waves get sharply refracted in the outer core. They get sharply refracted in the outer core. Okay, now, if you have a textbook, fine enough. Otherwise, you note this down. I'll read through some of the pages. Okay. अच्छा होगा कि अगर आप किताब लेके आए, because it helps you mark while I'm teaching. So page, I think 105 or 6 in my book. Okay, आपके बुक में क्या है नंबर बताइए? 104 है? Chapter number 5. 104? वो आगे पीछे होगा, doesn't matter. ठीक है? So I have told you about Earth's interiors initially. Okay. So how do we know about the Earth's interiors? The artificial sources. Okay. We know from the volcanic eruptions, from the earthquakes, from seismic. So I'm concerned about this one. And ये part आपने देखा हुआ है. Details of numbers you have seen once. I've talked about the pressure patterns, density patterns. I've talked about the patterns of temperature here. ये आपने देख लिया है. ठीक है? Now I'm looking at page 108 in my book. It could be 107 probably in your book, whatever. The heading is evidence of seismology. ठीक है? So it talks about the different type of waves, epicenter, primary waves. There are P waves. P waves are like sound waves. ठीक है? There are secondary waves or S waves. Okay, S waves like water ripples and so on. They can't pass through liquid material, whereas P waves can pass through the liquid material, but their speed is slowed down. Okay, and then there are surface waves. ये मैं बताया नहीं, I'll tell you this to you tomorrow. What are surface waves? Then we have the discussion in page 109 or 108, whatever. Okay, इसका behavior है. The first set of PS waves, we have PG, SG waves for granite. Look at that, all of you. Wherever you have this diagram here, okay, look at somewhere in between. There are three set of waves are only up to the lithosphere. उसके बाद में इसमें बताया नहीं गया है, but I have told you more on that. So within the lithosphere, we have the PS, PGSG waves, we have the PS waves, and we have the P star S star waves. Okay, the P star S star waves just before they enter the astronosphere. What I said is 7.8 and they suddenly fall to 7.3. याद आ रहा है वाला? The 7.8 वाला जो है, that is P star S star waves. Okay, so upper layers में PG SG waves. Okay, and they're faster. I gave all round numbers. As velocity around, okay, around less than 6 बताया था आपको मैंने. यहाँ पर बता रहा है 5.4 kilometers per second for the P waves. The S waves is 3.3. You don't need so much of details. And this layer corresponds to granitic rocks. This is the granitic rocks. Then the intermediate layers. This is after the Conrad has been crossed. Okay, the P star S star hai. So this is 6 to 7 kilometers per second, and the density is fine. Uske baad mein you have the PS waves just before they enter, okay, the astronosphere. So you can read this passage, ek bar, okay. And then I gave the table to you. What I did was, page 108 and 109, this conversation, according to Daly, according to Vandergraat, according to Arthur Holmes, according to Edwards, Seema, यहाँ पर लिखा नहीं है, ये सियाल सीमा वाला जो है, this is Edward Swiss, not mentioned here. So I put all of this into one table for you. You can go back. I have avoided the details in terms of decimals, but more or less this is the conversation. Okay. And finally, you may read last 2 pages of textbook, page 1112, 112. आपके बुक में क्या है? 111 है, क्या है? 1112, 112 है? Okay. Read the mantle discussion. In the mantle, it talks about all the depth, the composition, the Moho discontinuity. It talks about the density patterns, okay, and the core. You can ignore the last section called as search tectonics. इसको छोड़ दो आप. You can leave this one, okay, and the rest you can go through. ठीक है? Now see, one suggestion to all of you. Somebody asked me, sir, ये पढ़ने का pattern क्या होगा? Okay, so good question. I'll explain this to you. See, first is your class and your class notes. This is your first work. Okay, don't miss this one. इसके बाद में you must make your summary. Okay, once these two are done and you have understood, then you will open the book and whatever I have not told you or kitab mein hai, maybe a diagram I have not drawn kitab mein hai, you will add this to your summary. Is it okay, all of you? So one mistake students do is that they keep the textbook open and the notes open, and then they read, combine, and make a summary. Don't do that. You will be very slow. After 4, 5, 6 days or 1 week, you lose momentum. In fact, this morning, somebody came to me. He has done, koi topic hai. He has done part 1. He has done part 2, part 3, और कुछ part यहाँ छूटा हुआ है. And then he said, sir, मैं आगे बढ़ नहीं पा रहा हूँ because मेरा ये वाला part is not consolidated. So I'm going back and reading all of this again. And when I'm in control of this, then I will move towards this. In ideal conditions, this was the right method. But hota kya hai? If you're doing this and you don't have a sense of progress, you will only demotivate yourself. So along with understanding, you must feel like you're moving ahead also. So if you open the notes and you open the textbook, आपका पेस बहुत कम हो जाएगा. फिर आप बढ़ ही नहीं पाओ. पता चला कि ज्योग्राफी के साथ में बैठे हुए हो for 3 hours. After 2 or 3 days, you lose momentum. So your process will be this one. Class notes done with me. Okay. Be very alert here. This is whatever, 2.5 hours, you are with me. Then you do this. And summary, आप देख के लिखें, please. One mistake will say, I will memorize this and write in my own handwriting and own words. No. आप देख के लिखो. Open the book and keep noting down. This work generally must not take more than 45 minutes. अगर ये 2.5 hours के class है, this is the upper limit. अगर इससे ज्यादा हो रहा है मतलब you are putting efforts which is inefficient efforts. So maybe initially it'll take 1 hour, but come on up. Ultimately, I want the summary work to be over in 30 minutes or 20 minutes. Do this, then open the books. Okay. And conversion from the book toward the notes Again, must not take more than 15-20 minutes. It's a very fast reading because जो कुछ book में है मैंने आपको पढ़ा दिया है. And I'm telling you which paragraph, which section, which sentence. So the temptation will be, sir, मैं line by line detail पढ़ूंगा. It's a temptation because अभी नया नया शुरू किया है ना, तो अलग लेवल पे जोश होता है. Okay, but before आप औकात में आ जाएं, be selective, please. So don't open geomorphology page by page. Just that paragraph, that idea, that data, that's good enough. And अगर आपके notes में नहीं है, तो वहीं add करो, or maybe take a paper, write down and staple it there. ये पूरा काम should be over in not more than 1.5 hours after the class. In any case, the book reading I will not give you every day. I'll give you once in 4, 5, 6 days time. So आपके in your geography preparation, geography should not take you more than 1 hour more for consolidation. Sir, याद नहीं हुआ? Okay. This is not memorization. This is getting ready for memorization. Memorization will take more time. It's like, you have your notes with you. पहले memorization form में convert करो. I'm only converting right now. अभी याद नहीं हुआ मुझे. But while doing this, you'll realize, okay, 50-60% याद हो चुका है आपको. Why? Because you are doing it twice. You are doing it thrice now. So once I have taught you, I explained to you, I gave you the notes, 2 round हो गया. Then you do this, 3rd round हो गया. Then they read the book and add 4th round हो गया. By the time you have got 4th round, you already have remembered 40, 50, 60% of the content. Then you must find time afterwards, maybe once or twice in a week, whatever suits you, to memorize all of this. कि आंख बंद करके recall the entire synopsis, which will be part of the exercises also eventually. ठीक है? Fine then. That's for today. Now see, all listen. Today is Friday. On every Friday at 2:15, we have a current affairs class. Most of you are part of it. And tomorrow we will have your current affairs test also. So as a routine, please attend these sessions. It's your freedom. आप करना चाहें, नहीं करना चाहें. But I think it should help you part of your preparation itself. Those who want to attend, go take a break, drink some water, okay, have a banana if you have, or biscuit, and come back to the class again. Online, आपका अलग link होगा. You can click on that. ठीक है? I'll talk to you tomorrow for the next topic.